is a developer advocate. Amity, developer advocate at Amity, and a Google developer expert for Google Assistant and conversational AI. She has been involved in the tech community since 2013 as a volunteer, organizer, lead, or a speaker. In her spare time, she loves traveling, reading, doing puzzles, board games, and long walks with her dog. I heard she had 2 dogs, so maybe Eliza wants to tell us their names and breeds. I also have 1 dog, and I love dogs so much. So I am handing over to Eliza right now. Thanks again for Eliza coming to today's event. I will be here to assist you through the events. Also, Navati will be here. In the end, I will take our audience questions and ask you to you. So handing over to you now, Eliza. Thank you.
Thank you so much for the introduction. I'll share my screen to begin with. Okay. Can you see it okay?
Yes, we can see it.
Perfect. So the dog names are Idefix from the Asterix and Obelix cartoon, if you know it, because he's a West Highlander, and when I got him, he was exactly like the cartoon dog. And the other one is not a specific breed. Excuse me. Her name is Pixel. So not related to the phones, but very related to the pixel perfect UIs that I want to create. So I think that that's all about the introduction. I think that you already mentioned about the Google developer experts. I'm a developer advocate at Amity. Amity is building a social media SDK. So if you want to socialify your application, then you can use our tools for you to have a better experience. And I travel a lot. And by a lot, I mean a lot. And the funny fact is that the past year and a half, I've actually gone full mode in the virtual, like the digital nomad. So I actually don't have a house for the past year and a half. So this is literally me with my suitcase just going around. So if you want to find the slides after this session, you can find them over here. I will share this the link as well on my Twitter or in the rest of the social, and like that's going to be active after the session. So an overview. First, we are going to start with like where, when, and most importantly, why we use animations. And then we're going to start with the simplest one, which is, of course, and the most common example, basically, which is, of course, the ripples. Because when the user is tapping a button, of course, they need to see something, right? Then we will move forward with the rest of the animation APIs. We're going to see the lazy column as far as with some more examples, and then an extra library, Logi, and hopefully we will have more time for questions. So there is an unwritten rule in the mobile world. If you want to show your user, if they need to use your application or to choose your application over something else, you basically have 20 seconds for them to make up their mind. And this does include splash screens, it includes like logins, it includes everything. And if you're wondering how much those 20 seconds actually are, it's just about as much time I've spent in this slide alone. So what can we do to keep our users interested while we're performing all the necessary jobs that we have to? Well, we add motion. Motion can be integrated throughout the entire application, and if it's used wisely and in the places that it has to be used, then it can really make a very enjoyable and natural experience with the user, and they won't even realize what's making this experience so nice for them. In addition, it can also help us to surprise them nicely, if we have some blocking actions. For instance, if the user cannot do anything without logging in our application, then we need to have some motion over there, not a static screen, in order for us to catch their attention and their eyes while they're going through a very boring process. And of course, that doesn't go only at the beginning of the application, but throughout the entire application. So if we also have another blocking action, like uploading something, and we can't do anything without like the user seeing the upload, then we can still use motion for us to make things a little more interesting. So we covered the when and where to add the motion. Well, we covered most of the why, but let's see more about the when and the where. So as we mentioned, ripples is the most basic animation anyone can basically add. So before going there, there are just two rules when you add the animation. The first of all is that it can't be destructive to the user, and it can't be blocking. It has to be meaningful. Like if you have a button, it has to provide some kind of feedback, but it shouldn't be blocking the user from moving forward if it's not like a blocking action. So for the ripples, as I mentioned, it's basically the most basic animation that we can have. Over here, we can see how easy it is, and we can see that it's basically just a function in our modifier. And we add the interaction source, we add the indication, and we will see what that means. And that's it. Then you're done. You already have all the ripple animations that you want in that specific clickable view. And we see over here that it has like a bounded and true or false. So if it's bounded, it looks like this. It's basically bound to whatever view we tap. If it's not bounded, then it's not tied to a specific view. It's just on the place that the user will click. So now that we kind of already know about like the most basic animation, then we were going to go forward with the rest of the animation APIs. And Jetpack Compose does provide very powerful and extensive APIs that make it easy for us to implement almost everything that we want for our UI, our app's UI. So following the documentation, you will find a very useful diagram, which is also very confusing and overwhelming if you don't know what it is. So the orange boxes are indicating the APIs, and depending on your use cases, this will help you decide which API you're going to use. So in this presentation, we will see most of them, if not all of them, along with some more, as we mentioned before. So many Jetpack Compose animation APIs are available as composable or as functions, as we saw with a modifier function before. Those are called like the high-level APIs. And of course, they are backed with lower-level APIs, which are built with Kotlin coroutine suspend functions. So these are the high-level APIs. Those are the low-level APIs that we're going to see. And we are going to start with the high-level APIs. And to begin with, we are going to start with the animated visibility over here. So the animated visibility will basically animate the appearance and disappearance of the content. We can see that we can use it as any of the components, like the row or the box or a column or anything that we had. We encapsulate with it any UI that we want to animate their visibility. By default, the content appears and disappears in and expanding, and then it disappears by fading out. And it's shrinking, sorry. So you can see here the default one. So it appears, it fades in and expands, it disappears, it fades out and shrinks. Of course, there are a number of built-in transitions we can choose from, both for the entry transitions, but also for the exit transitions. And we can see that it's mostly like one-to-one, but of course we can mix any of them that we need for our application. So a fade in, a slide out, a slide out vertically, or a scale, a spring. All of those are applicable, and we will see how we can use them in, if not all of the APIs, most of the APIs that we will see. So over here, for instance, we can customize the transition by just specifying the enter and the exit transition, as simple as that. And then instead of having the default one, as we saw, then we're going to have this one. And on top of that, we can actually combine multiple with just the plus sign. So we can combine as many as we want. Like this example, which is sliding in, it's fading, and it's sliding out and it's fading for the exit. Or this one, which is going to slide in and fade, and then it expands and fade as well. One of Android Studio's most useful tools when it comes to animations is the animation preview. So we're going to see over here, there is this preview box that we can open, and we can check our animation, we can play it. We can also check if we want the enter or the exit animation to be played. We can specify the speed that we want it to play, but we can also drag and drop where we want it so that we can pinpoint exactly exactly what animation we want, and to make sure that it goes smoothly from one state to another. So that was for the animated visibility, and time to move on to our animated content, or the crossfade. The animated content composable animates its content as it is based on a target state. So as before, we can also see that we can use it as any composable that we have. We encapsulate over here again what we want to be animated. And then we have the transition spec, which is all of the animations that we saw before, which is optional. And then we have a target state, the expanded or not expanded, basically. And then on the state, we have the content. So this is something like this. Okay. So as we mentioned, the animated content is a high-level API. And in our example, we only had just one animation. But if we had multiple animations, then we can have the transition and the update transition over here. The transition is basically if we want to combine multiple animations, or if we want to have a better control over our animations. So we create a transition object, we set over there the state, and then we use the extension function of the transition of the animated content, and then we do everything over there. As we see, it's not a huge difference, but it does add a lot of control in what we want to do. Just keep in mind that the animated content composable is currently experimental, although I think that it's been in this state for quite a while, so I think that it should be stable very shortly. So it's very similar to the animated content. We also have the crossfade. And while the animated content composable animates the content between two states, the crossfade composable animates between two layouts. So with a crossfade animation, of course. The code, of course, is very similar over here too. So we have the crossfade instead of the animated content. And we can have the animation spec again if we want to, it's optional, and just our target state. And then this is going to be our animation. We see how different one from the other is. Like this is very visible a crossfade, while the other one is indeed an animation of the content. So we saw the animated content, we saw the crossfade, we saw the animated visibility. We are going to go to the animate content size, which is also very similar to the previous ones that we saw. So the difference with that is that in contrast with the APIs that we've seen so far, the animate content size is a modifier and it's not a composable. So the content size animation is like this. We see over here, it just expands and shrinks according to the content size that we have. So we are going to use this with any composable that we want. We're going to add it to the modifier. And basically that's it. That's all that you have to do for the content size, nothing more. So lastly, we have the animate as state. The animate as state are functions, and they are the simplest animation functions that we have in Compose for animating single values. You only have to provide the end or target value, and then the API will start the animation from the current value to the specified value. There are a few options available, as we can see over here. Out of the box, it supports like floats, colors, sizes, DPs, and like much more. But additionally, we can very easily add support for other data types by providing a converter to the animated value as state. And that will take any generic type. You can have an enum over there, for instance, or anything else that you want. So we'll start without any animations first, just for you to see how, like, the difference between having the animation and not having the animation. So over here, this code is just going to have to change the color of a heart, basically. If it's clicked, it's going to go from red to like a pink, and then vice versa. And it looks basically like this. Now, if we want this to be animated, then first of all, we're going to set the color filter over here, but the color changes to this. So instead of just saying, if it's animated, do this, else do that, we're going to use the animate color as state. We're going to have two target values, if it's animated and if it's not animated. And then that's it. We don't have to do anything else. The platform is going to take care of animating through one value to another one. And under the hood, an animation object, or like an animatable object, will be created and remembered, and with the first target value as its initial value. From there on, anytime that we supply this composable a different target, then it's going to animate from the value that it's currently at, like the value that it's remembered, to the value that we specify. If there is already an animation in progress, then it will automatically stop the animation that is going on, and it will automatically start to animate from the very last value of that automated progress, automated animation to the value that we specify. So if, for instance, it's not completely red, but it's going to pinkish, and then we stop that animation and we get back to red, it's not going to start from like the end color, but it's going to start from the color that it used to be when we stopped that animation. And the same goes for the velocity of it. So if it was going with an X velocity, then going to the other state or to the other color, then it's still going to get the same velocity. So we see how very complicated animations and very complicated state handling is actually becoming really easy with just a single line, like the animate color or the animate something as. And of course, this is going to be like our new like animated heart. And as it goes with everything that we've seen so far, we can also specify exactly what animation, like what kind of animation we want. For instance, if we want this to go like a little smoother, we can use the twin animation, and then it's not gonna load. Oh, that's interesting. Okay, so those two slides are not gonna load. Basically, it's the very same animation, but of course, because we have the twin over here, it will go from one color to the other one very, very, very slowly. And the other slide that it's not unfortunately loading is that we can also combine those applications, those animations, as many as we want. So instead of just having the color over here, we can have the color, and then we can have another one for the size. So we can have like val size by animate DP as state. And then in our image, we're not going to just set the color filter, but we're also going to have the size. And then from the size, it's going to be like the size.value to get the size, also a nice animation over there. And we can combine as many of them as we want to in a single image alone. Okay, so that was all for the high-level APIs. And now that we're a bit more like experienced with the high-level APIs, we're going to see like the lower, sorry, the lower level APIs. Of course, every API that we saw so far, it's on top of the low-level APIs. Those low-level APIs, though, should only be used only if we don't really if our use case is not covered from the high-level APIs. And this is basically because everything that we've seen so far, it's going to be like we're going to manually have to take care of basically all of them. So those are like the high-level API, the low-level APIs, excuse me. We have the animation, the animatable, the animation state or animate, and then the update transition, and then remember the infinite transition. We're going to start with the animatable. And compared to the animate as state, using animatable directly gives us like a finer grained control on several respects. So I'm going to go back to our heart animation, and we see over here, like this is exactly the same code that we had before. Let's see how we can go from a higher level to a lower level. So instead of just having the animate color as state, I am going to remember an animatable, which is going to be a blue color. And then we are going to animate that color from one to another if the heart is pressed or not. But lower level APIs, as we mentioned before, are on top of the suspend Kotlin functions. So this actually needs to be inside suspended function. Also something to take care of over here in animatables, we can now have a different initial and final value. So we can now have two values instead of just one. And of course, over here, instead of just having the color, we're going to get the color.value. And this is exactly the same thing. So we see how the high-level animation APIs are actually on top of the low-level APIs, and that's why we don't really have to reinvent the wheel. And if a high-level API is covering our use case, then we should just use that one instead of just trying to juggle a lot of things all together. So that was it for the animatable. Outside of the box, animatable supports like floats, colors, but also other data types. And with those data types, we just need to create a converter. And one more difference between the animatables and the rest of the animation APIs is that we can use this API outside of our composable functions because it's basically just the suspend function. So we are going to move to the transitions, and transitions manages one or more animations as its children, and it runs them simultaneously between multiple states. So everything that we've seen so far, it was basically one animation or multiple animations, but in just one object. Now we're going to see how we can choreograph a lot of different animations for a lot of different objects. So we create over here like our transition object with the update transition and our target state. We're going to have like two background colors as we see over here. And then we are going to use the extension function animate color of the transition. And then we are also going to change the according to the target state, it's going to take, of course, like which value it should actually get. That target state over here is just a Boolean for me that is loaded, but it could be actually anything. It could be like an enum class, and it could have like every different state in our application that we would like. So the code that we saw before basically translates to this. And this is just, again, with our value, but we can imagine how much different, like if it's loading, for instance, it can have a different background. If it's already loaded, then it can have a different background. If it's uploading something, it can have a different background. So every time that we have a different state in this layout, then we can basically update any composable with any value that we see fit. And of course, as with the previous ones that we saw before, it's not just the high-level animation APIs that do get the transition spec, but it's also the low level, of course. So over here, we see, like, again, we can add twin so that it will slow down a bit the animation. The states over here that we see, so as we saw with the animate as state, we can also use any of the animate different extension functions over here to define which animation we want. So we see over here that it has like the animate color, it has the animate float, it has the animate DP, and so goes on. And that is for the updated transitions, which is basically for transitioning from one state to another state within the same layout. But what happens now, let's say if we want something that we want for it to have like an infinite, then we have the remember infinite transition. Infinite transitions hold one or more children, like a transition object. And then the perfect example would, of course, be a loading screen like this. So you can see over here that this would have been one of our states of our main screen. And what we have to do is that we just need like the remember infinite transition object, and then we just animate any flow that we need. And If we want to have more animations, then we add this, but basically this is where everything stops. This is if you want to add some more fine control into your application, into your animation. Whew. So we found out how to do like ripples. We found out how to animate sizes, how to animate colors, and what else? Like how to make our loading screens. And now we're going to see like the lowest level animation API available. So many of the animations that we've seen so far were built on top of that animation API. Animation should only be used if manual control of the time and the timing of the animation is crucial. Animation is stateless and it does not have any concept of life cycle. So that means that we have to take care of everything if we're going to use the animation. So whenever we can avoid it, we avoid it. But other than that, if we can't avoid it, we use the animations, and then it's not a bug, it's a feature, right? So those were all of the basic animation APIs that Compose brings like outside of the box. It comes with the compose functions that we saw. It comes as the suspend functions that we saw and the composables. But what happens to the rest of the animations? We have like changing between screens, like the navigation animations. We have recycler views, or how they're called now, lazy columns. Like what happens with all this? Well, we got you covered though. There are so many libraries, and my favorite one is the Accompanies library, because it's super easy to implement and it covers whatever the basic APIs basically do not cover. So this should be like a very familiar piece of code if you're using Compose. And the first thing that we need to do is change the navigation controller to an animated navigation controller. And then we also change the navigation host to an animated navigation host. And that's it. Then we don't have to do anything else. But of course, if we want to do something more, there is a way to do that. So we can specify the enter, the enter transitions as well as the exit transitions. And again, we can specify as many transitions as we want, and it works exactly the same way as we saw there with the previous APIs. So this is without any navigation animations. And we can see how blunt and how plain it goes from one side to the other. And this is with the navigation animations. So we saw like a much nicer transition from one screen to another. If we're coming from the dark side of the views, then you are familiar that recycler view would come with animation changes outside of the box, and it would automatically change if something was like the sorting, the automated sorting, the adding as well as the deletion of some items. And lazy layouts provide, thankfully, exactly the same animation. So for the lazy layouts animation to work, we don't really need to do a lot of stuff. But the most important part is for the lazy column to understand how to identify its item. And to do that, we're using the comparators. So we have over here a comparator for each visit. So, and we're using the IDs. So we're using the ID to the left item and to the right item, which is basically just all of the items in our database. And then we are going to remember the state of that comparator. And finally, we are going to short with that. And once it's in place, then there is a modifier extension So we're going to use that animate item placement, and that's it. That's all that we have to do. And we can see here how it is without being automated when we add some of the items, like the visits over here. And when we delete it, it's not really being deleted very nicely. You can't really see which item is actually deleted. But if we go to the animated example, and then again, we see how adding, it's a little nicer, and it's a lot nicer when it comes to resorting the list. But also when you delete something, then you can actually see which item was deleted, and you don't really like need anything like to be checked over there. For more complex animations like an After Effects image, then we can use Lottie. And Lottie is one of my favorite libraries out there because designers tend to get very creative, and some things just cannot be done with like simple APIs. The best example for a Lottie one would be like a boring empty screen, which can become very pleasant to the eye. So instead of just the user to open up to a plain, like no seed is found screen, then we can have something like this. And it's also making the user to actually want to add something over there. Thankfully, it's also very easy. It's just a 3-line code, basically. So we have the composition by remembering the Lottie composition. And then what we do is that we have the Lottie animation object, composable, excuse me. And then we just pass the composition over there. We can also have the animation state if we want something like the animation state. So over here, basically, it's done. Like this is all that you need. Basically, you have the composition, then you create that composable, the Lottie composable, and this is all that you need. But this is only going to run once. If you want that to run multiple times, for instance, if you have like an upload or loading screen again, then you can create an animation state as here, and then it's going to repeat every like X seconds by using the animation state over here. So this is still from the Lottie library. You use that state, you have the trigger, and then every X animations, that's just going to repeat itself. Ooh, and finally, we have my personal favorite. So animated vector durables. And this is just a single animated vector durables. It was created by Nick Butcher. He's an Android developer at Google. And it combines so many things. It looks so complicated, and yet it's the easiest thing to actually do in Android. So as you can see, that pin it appears like it's moving, but it's like the dots that are moving, and then some dots are shrinking, some other ones are expanding. The pin is morphing. There are so many things going on, and yet it's so simple to do. So all you have to do is to create the animated image vector with your vector. And then instead, for our painter resource, we just use the remember animated vector painter, and that's it. That's all that we have to do. There are so many more animations, like collapsing toolbars and physical-based animations, the shared element positions. Of course, if we want something more flexible, like the canvas ones, there are a lot of libraries out there for most of those things. But even the most difficult and the most complicated, for instance, collapsing toolbar, can be done with some of the simplest APIs that we've seen so far. And if not, then there are more layouts, like the motion layout, that it can actually help us a lot to create those animations. Thank you very much. I think that we have some time for the questions.
Yes, thank you, Eliza. We have some time. Can you stop sharing your screen?
Of course.
We have several questions in the QA section. Also, I have some questions, but I want to ask the Q&A section first. So what language is used in the code samples?
This is all Kotlin. This is
Yes.
this is Compose, and it's all Kotlin.
Okay, thank you. What are some of things you wish were covered by these APIs?
I think that there are a lot of things that cannot really be covered by just one API. For instance, one of the most difficult things that I found that a developer can do is the collapsing toolbars. So I wish that there was at least some of the scenarios, like the most basic scenarios, that would have been over there, so that it's a little easier to do some very straightforward things. But other than that, I really found that the animation APIs that are currently available do cover 99% of the use cases that you're going to have. And then the other and with that, actually, I do have the accompanied library inside. It's not from the Compose, but it's still maintained by the Compose team. So
thank you so much. We have another question. How different is it to implement animation with Compose Vesaire XML?
It's actually very different. A lot of the APIs are kind of the same, but the high-level APIs that Compose currently has are not that much available in the view system, the XML system. So for instance, if you want to do color transitions, yes, you can do it. It is a higher level animation API for the XML, for the views, but you will have to take care of everything that goes for the life cycle, something that you don't really have to do with the high level animation APIs that are for Compose. I think that this is the biggest difference. Basically, for the Compose, all of the high level APIs do take care of the life cycle for you, while for the views, most of the times you will have to take care of that yourself.
Thank you. We have 3 more minutes, so I will ask some of my questions to you also. How they can reach you after this event when they want to ask their questions, through Twitter or maybe LinkedIn? Which platform do you use regularly?
Twitter is you can find me over there very regularly. Other than that, yeah, LinkedIn also works. Basically in all of the social, it's still Eliza Camber. And of course, you can also reach to me through Amity. So you can just shoot any questions to Amity and the team will just redirect those to me.
Thank you so much. We have one more question on the chat. What is the animation scenario that you most enjoy developing at work?
I most enjoyed. It has been a few scenarios, so I don't think that I have a favorite one. My favorite one was one of the most difficult ones. We were 2 developers or 3 developers trying the same thing, just to make sure, just to check which one is actually going to work. It was basically videos, and then you had to animate through video transitions. And those videos were basically different, different views, because we were not using Compose back then. So it was like different views, and you had to animate from one video, basically from one view to another view. But when that view is actually a video, it's not easy. But when we did have that working, it was the best feeling in the planet.
Thank you so much. Also, we have another question from Laura. What resources you have been the most helpful for you while learning animations?
The documentation, especially for Compose, the documentation is perfect. I didn't really miss anything. It's very straightforward. The chart that I had for you, so that you can actually like decide which kind of animation you have to use, was also from the documentation. So I think that this is like the best resources that you can have. And for all the rest, there is Stack Overflow, right?
Yes, Googling is the most important part of the developments. Thank you so much for today, Eliza. It will be wonderful to hear your insightful introductions about the Compose. Thank you so much again. I want to add a little bit of information about, we have an Android study club also. We will start with the beginnings. Also, we started actually yesterday with the beginning course from Google. After that, we will go through the Compose course. So if you are interested in that, please find us on Slack channel. So we would love to host Eliza again when we are going through the Compose education together. So thanks, Eliza, for today, and thanks, Navati. Also, a quick note again, if you want to donate and if you need any additional help with the process, you can find me on Slack or LinkedIn as Selen Demir. So thanks again for joining, guys. Thank you so much. So take care.
Thank you so much, folks. Thank you so much.
Thank you for having me, and thank you everyone for joining. I hope you enjoyed, and if you have more questions, feel free to reach out to me.
Thank you, everyone. See you.
Bye. Thank you.